Good day guys, I am Cloyd Vincent Montealto, second year civil engineering student from Nueva Ecija University of Science and Technology. And in this video, we are going to solve some sample problems that you might encounter when you take the subject engineering and data analysis. So without further ado, let's get into the video. So for our next problem, this is taken from the topic cumulative distribution function for discrete random variables. So our problem for this topic is a box of 850 marbles contains 50 blue marbles. 2 marbles are selected at random without replacement. Let X be the number of blue marbles in the sample. Find the cumulative distribution function of X. So our first step in order to find the cumulative distribution function of X is to find the sample space. So our sample space for this problem is, okay, so 2 marbles are selected at random. And the box contains 50 blue marbles. So there's a chance that you might get blue. So if you draw 2 marbles from the box, you might not get any blue at all. So let's denote the not blue marbles as N and the blue marbles as B. So if you draw, you might get 2 non-blue marbles. So you might get N and N. Okay? So in other situations, you might get a non-blue and the blue and a vice versa of that. So you might get a N, B, or a B and N because this is a 2 selections. Okay? So for our last sample point, we might get 2 blues if we draw from the box. So we can get a blue and blue. Okay? So our sample space will look like this. Okay? Okay, so our sample space looks like this. So our next step is to find the values of random variable X. And since we only draw 2 marbles from the sample, the chances of getting a blue marble can only range from 0 to 2. So the values of our random variable X can only be 0, 1, and 2. Okay? So here it is. 0, 1, and 2. So let us find now the probability distribution for the random variable X. Okay, so let us create the table. 0, 1, and 2. Okay, so here is our table. 0, 1, 2. So for f of 0, okay, f of 0, this is the probability of N and N because there are no blues in that sample point. So we will only get the probability of that. So for the probability of N and N, okay, so probability of N and N. So since we draw here without replacement, so we will apply the N principle here in this probability because if we draw, we will get, in our first draw, we will get N, and then for our second draw, we will get N. So N and N. So we will apply the principle of N here. So the total number of non-blue marbles in the sample space is 800 because 850 minus 50 blue marbles is the total number of non-blue marbles. So we will get 800 over the total number of marbles, which is 850. So this will be the probability of this N, the first N. So applying the N principle, we will multiply it to the probability of this other N. So multiplied by, and since there is no replacement, the total number of the non-blue marbles now will be 799 because we drawn the one non-blue marble on our first draw. And then the total number of the marbles now will be 849. Okay? So solving for this, we will get 0.886. So f of 0 is equal to 0.886. So we will write it on our table, 0.886. Okay? So for the next value of x, which is 1, so f of 1, we will now solve for the probability of, since in our sample space we have two sample points, okay, this one and this one that has one blue, we will apply the principle of OR here, because if we analyze the problem, we can say that the probability of a random variable x, which is 1, can be this one, can be the probability of this one or this one. So we will add the probability of these two. Okay? So the probability of NB plus BN. And applying the same principle as the f of 0, we now have we will need to find the probability of the first draw and then multiply by the second draw. Okay? So total number of non-blue marbles is 800 over 850, and we have a total number of blue marbles as 50. Okay, so this is multiplied by 50 over, since we draw one marble from our last draw, so the total number will be now 849. Okay? Plus the probability of B and N. So, probability of B is 50 over 850 times the probability of N without replacement. So, we have 800 over 849. So, solving for this, we will now get 0.111. Okay, so f of 1 is 0.111. So, we will list it down to our probability distribution table. So, our last value of x will be 2. So, we will now solve for the probability of 2. So, probability of 2 is equal to the probability of B and B. So, solving for this, we will get probability of blue marbles is 50 over 850 times, since B and B and without replacement, 49 over 849. Okay, so solving for this, we will now get the values of f of 2, which is 0.003. Okay, here it is, 0.003. Okay, so our probability distribution table is now complete. Okay, so this is the probability distribution, but we are asked to find the probability or the cumulative distribution function of x. So, okay, let's move on to it. For the cumulative distribution function of x, it will be now like this. So, f of x, since we all have the probabilities for the random variable x, so we will now have f of 0. Okay, so let me show you first. So f of x, then f of 0 is equal now to probability of x less than or equal 0, which is the probability of 0, which is 0.886. And for f of 1, we have probability of x less than or equal 1. And this is equal to probability of 0 or 1. So we will add the probability of 0 and 1. So 0.886 plus 0.111. So f of 1 is now equal to 0.997. Okay? 0.997. So for our last point, we have f of 2, which is equal to probability of x less than or equal 2. So it's equal to probability of 0 or 1 or 2. Okay? So we will add the probabilities of those. We will now get 0.886 plus 0.111 plus 0.003, and this is now equal to 1. Okay, this is equal to 1 since we add all the probabilities of x. So let's do it. F of x now is equal to, okay, let's draw the figure. So we have 0 here, 0.886, 0.997, and 1. Okay. 0.997 and then 1. Okay. Like this. So you see this figure here. So for f of 0, we have x is less than 0. Okay. So for 0.886, we have 0 is less than or equal x less than 1. Then for our 0.997, we have 1 less than or equal x less than 2. Okay. This. And for our 1, we have 2 is less than or equal x. Okay, like this. And for the graph, it will look like this. So f of x. Okay, f of x. We have here 0, 0.886. Okay, okay, let me just list down all the values. 0. We have 1 here, 0.997, 0.886. Okay, so in this part we have 1, 2, and okay, 1 and 2 only. So this is x. Okay, it will look like this, the first part of the graph. Okay, so for 0, the arrow pointing this is pointing there is towards here, since it does not have any probability. Okay, you see this arrow here. So for 0.886, the line will be from 0 to approaching 1, but it does not equal to 1. Okay, so it will look like this. This is for 0.886. This is the one. Okay, for 0.997, we will start the line from 1 and approach 2, but not equal to 2. Okay, like this. And for our value 1, we will now start from 2, and then we will just put an arrow to it. So go like this. Okay, so that's it for this problem. Thank you for watching.